Hey, how's it going everyone? Welcome to this video. Today we're going to have a look at symmetrical trig points, looking at angles for 30 degrees, 45 and 60 degrees. And when you think of these three angles, immediately should recognize the two exact triangles and be able to draw those. The other option is, if you remember how to draw up the table and put all the points in, that's fine as well. I like to use the triangles. It just is easier for me to remember. So first one is looking at sine of 45. So we've got 45 over here. Sine of 45 is going to be 1 over root 2 or root 2 over 2. Now using that value there, we can have a look at the unit circle and we can place 45 degrees, and that's the one that we find over there. We can also find, if we use this one here, so that would be a triangle, and this would be the same triangle, it's just flipped the other way, and that's also 45 degrees from the horizontal. And we can actually say, well, that horizontal is 180 degrees, so that point there, going from the zero, would be 180 take 45, so we'd get 135 degrees in reality. But I can make a triangle instead by doing it like that. The other option is I can actually flip that as well, going the other way across the horizontal, and it would be 180 plus another 45. So instead I'll have 225 degrees. And then over here I can do the same thing. I can flip this one across the horizontal and I'd get the same triangle. Except now I've got, well, 360 minus 45, which would be 315. So now all of a sudden I've got three different triangles. And if you remember from a couple of videos ago, we found that all values are positive in the first quadrant. Only the cos and then tan, that should be tan, and then sine. So they're the only values for which the other trig functions are positive. So to be able to evaluate what sine 45 is, well, sine 45 is clearly square root of 2 over 2. But from this values, or from this information here that I've shown, where we can draw other triangles, or the same triangle, just a different way, I can now work out what sine of 135 degrees is. I can work out what sine of 225 degrees and sine of 315 degrees. And how do I do that? Well, sine of 135 is simply the triangle of sine of 45. It's exactly the same, except I've just flipped it over the other side. And which means if it's the same, I'm going to have the same value, square root of 2 over 2. The only thing that changes is when we talk about our signs, so a positive or negative. We're in the second quadrant, it just means that I have a minus square root of 2 over 2. And for sine 225, well, that's exactly the same as sine of 135, except I just flipped it across the horizontal. And that's the same as sine of 45 from the start. So again, I have the same value, square root of 2 over 2. Except, again, I'm in the third quadrant, means tan is only positive, which means this has to be negative. And sine of 315, well, that's the same as the original, just flipped across. And we're in the fourth quadrant, which means it is positive. So using a simple triangle, we've kind of led to being able to work out all these different angles, and we haven't even touched our calculator. So this is symmetry properties. And we're going to do exactly the same thing for cos and tan. So let's take a different angle now. Let's say cos of 60 degrees. Well, cos of 60 is 1 over 2, adjacent over hypotenuse, using this exact triangle. And I can work out, let's draw up a second circle here. Okay, so 60 degrees, roughly over here. Well, that's the same as this triangle here if I flip it vertically, except I'm going to have an angle of 120 instead of 60, simply by going 180 take 60 gives me 120. But I'm not going to use 120. I've now got the same triangle, just flipped a different way. And then I'll do the same thing for the third quadrant. And the same thing for the fourth quadrant. And now all of a sudden I can now work out what cos of 120, cos of 240, and cos of 300. Because they're all the same triangles, they're all going to be a half, except some of them are going to be positive, some of them are going to be negative. So cos of 60, that's in the first quadrant, so that's positive. Cos of 120 is in the second, that's positive as well. The third one is in the third quadrant, and only tan is positive in that area, so that has to be negative. And then cos of 300, only sine is positive in there, so that's also negative. And so all of a sudden, using the one triangle, one value, I have 4 different angles I can work out. And you can check those on your calculator. Don't just take my word for it. So we're talking about angles here in degrees, and really we're starting to look at radians. And essentially they're the same thing, it's just a different way of talking about it. So sine of 45 is the same as pi over 4. Well, 135 degrees, if we're now talking about in terms of pi, 180 is 1 pi, 45 is pi on 4, so 135 is going to be pi minus pi on 4. So it's going to be 3 pi on 4. Sine of 225, well, that's the same thing as pi plus pi on 4. So I'm going to have 5 pi on 4. And then sine of 315, well, we found that by 360 minus 45. Well, it's the same thing as 2 pi minus pi on 4. So we're going to have 7 pi on 4. And essentially we have the same numbers. So root 2 on 2 minus root 2 on 2 minus root 2 over 2 and root 2 over 2. And I can do the same thing for cos, except instead of cos 60, I would then have cos pi on 3. Cos of 120, cos of pi, take pi on 3. So I would have 2 pi over 3. Cos of 240 is pi plus pi on 3. 4 pi over 3. And then cos of 300, well, that's 2 pi take pi on 3. So I would have 5 pi over 3. And there they're going to be the same numbers and found exactly the same way as we did with the degrees. So half, half, minus half, minus a half. So that's symmetry properties. I didn't have a look at 30 degrees, but it's essentially exactly the same as those two ways that we've done here. And so in the next video, we're going to have a look at a couple of different examples, which aren't so easy to find. So thanks for watching at the moment. Stay tuned for the next video. Thanks.